All right, so welcome everyone to the community call. It's not April, it's August 8th, 2022. Today we are going to be hearing about DCite from CINA. It's a project having to do with citations through DeSci Labs. Very excited. I don't know much about it, so I can't wait. First, really quick, couple housekeeping items. We've got a couple talks coming up from some folks at DeSci Labs. Philip will be talking about reproducibility at Reproducibility, TEA, which is an event on Wednesday, August 10th, I believe. It's online. You can check that out. We'll have links and everything after the recording and connected to the recording when it's uploaded. And then Eric will be joining Crypto Altruism on a Friday, talking about DeSci Labs, I imagine. Otherwise, that's about it. I'll invite everyone to our various meetings throughout the week. We've got community calls every Monday at noon. We hang out for about an hour after those calls too. So between noon and 2 p.m. Eastern, we're just sitting here in chat, loving talking about DeSci or DeSci Labs. Then we've got some onboarding every Wednesday at 9 a.m. Eastern. And then if you're working with DeSci Nodes, the product that comes out of DeSci Labs, you can join us Tuesdays at 1 p.m. Eastern for some product support. We're also starting journal clubs that are doing things every other week now. So I think the next one is going to be Friday, August 19th at 11 a.m. I'm not sure if we got a journal yet, but we will by then. So join us for a fun discussion. Last week we did Carla's master thesis. It's very interesting. So with that, I will just toss it off to Sina here to talk about DCite.
Hey, thank you very much. So I'm Sina. I am working on engineering at DeSci Labs. So I work primarily on the Nodes product, but we have many other projects and components that we're building out. So as we were developing the Nodes product and developing the on-chain indexing, there's a few different things we had to consider in terms of creating a immutable kind of so we have the immutable CID, right? But the thing is, as content changes and versions update, right, we need to be able to create a scheme where we can reference multiple versions within a research object as it gets updated over time. And but we need to also preserve the integrity, of the data that's been, committed. So the way we're doing this to be the most efficient is using CIDs, right, and indexing these CIDs. There are other approaches that we can implement. There's certainly the approach of doing a DID store and then taking the entire state of that DID store and kind of indexing that state, and so you're ending up being doing badging operations. And so there's either way that you do it, you're going to end up with an identifier that's probably going to be pretty long. And so in general, we want to be able to reference these works. So if we have like a node pulled up, you're going to want to be able to take this, and then be able to have a reference to it from perhaps a different node or different paper. You want to be able to get cited, right? And so as we're exploring putting this stuff on chain, we have this basic URL kind of scheme. There's a UUID followed by CID. CID is basically like saying, hey, this is the version that I'm referencing specifically, and this won't change. UUID, you can actually use this as a shortcut. So by just going to the UUID, you would get just the latest version. We describe a URL schema here, where there's also the ability to reference individual components. So you could have a component, code component. You could reference also specific pages within the manuscript component. And so as we're building this out, we don't want to create issues because of long URLs and that sort of thing. So what we want to do is have an academic friendly URL. And so we think using something that looks like this, like dcite.org/a number, and that represents a very academic friendly way to cite these research objects. Additionally, we introduce a schema to resolve to individual components within that. And because we're using CIDs, we can guarantee that the underlying data is immutable at the time of storage, and therefore it is safe to use different schemes to access the underlying information. So in the case of a research object, we could use something similar to JSON path. So something like this, right? And so we're experimenting with a couple different schemas to make sure that they work across, all formats. Like, if you make sure all the email editors can pick it up, right? And, kind of be able to resolve these links in a way that's like friendly and works with everything. So we're doing a bit of testing here and trying to come up with different schemes that, are going to be able to work long term. So something like this would be like version 0, component to page 4, right? Something like that for short form. And then we would have an extended form that would look something like this crazy long URL. So, we don't want to have a crazy long URL. We'd rather have a shorter URL, something like this. Something that is a bit of it is human readable as well. So if you're citing some individual code or method, you can do that. You can also, refer to different versions of components as stated. So this ends up being a bit better and a bit more user friendly. So we've built something out that does this. So we call it DCite, DCite.org. And then the idea here is that these references are all in a smart contract, and so we're just incrementing basically a list of entries on a smart contract, and that's like a decentralized backend that's permissionless. Anybody can actually add an entry, and it ends up being this like URL shortener that works a little different than a normal URL shortener, but it's also decentralized. And so let's say we had this, really long URL that I had here earlier. So what we would do is only reference the part that's the unique identifier, and we put it in here. And then, so all these costs would actually be covered by DeSci Labs or DeSci Foundation through any work that's been done through the Nodes product. And so we would that would be like, we would sponsor that, so that's not a problem. And then the idea would be that any work that goes through, we sponsor the ability for it to be have a short URL and make it friendly for citation that just comes out of the box. And then we're doing this on a testnet. So on Goerli testnet. And so, basically, this would actually allow us to do some pretty cool stuff. So because we can trust that this particular URL, the short form of this super long URL, we can actually do stuff like import a code component into Python. And so then you can actually, if you did have code in Python like available, or a different language that would support something like this, you would be able to refer to it and actually call it in a script. And we thought that would be super cool to demonstrate this. So this is something that we're working on right now. And so this allows us to create a user-friendly kind of way to refer to these research objects. And then you can not only cite them in a paper, but then you can actually import the code. And so DCite is part of this, kind of infrastructure that's permissionless, and anybody can use it, and then we'll just sponsor the usage of it. And what's really cool about it too is that the difference between this and a normal URL shortener is if I go over here and I type in some path test. So what's happening here, it gets resolved, and then so this didn't work because this is not a valid URL, but you see that it did actually paste in at the end the fragment that I had. So with one DCite URI, you can actually resolve to any component because we know that the UID CID combination is going to be unique and immutable. We can actually refer to stuff inside of it using using quite a flexible schema. So we can actually use JSON path or a short form schema that we come up with, and then basically you have one, instead of having like 10 DOIs per research object, potentially where you have like every piece of code and every PDF individually assigned a DOI, which each costs like $1 on DOI.org. You could just get one DCite URL and then guarantee with that one for less than $1, which would be sponsored by us. You would then be able to, in a granular way, cite and refer to everything in a research object. And because of the property of immutability and also the decentralized storage, this ends up being a much more robust system for citing research. So yeah, with that, I mean, that's the most of the overview. Happy to take any questions and discuss further.
Thank you, Sina. That's awesome. So I'm sure there's quite a bit of you with some pending questions. That was quite a technical conversation, but in any case, the real powerful thing with this approach is that we can basically upgrade the whole system used to ensure persistent identifiers in science, right? And right now, the dominant system is the DOI system on DOI.org. And what we're proposing here is a powerful alternative because essentially it protects the underlying content. It resolves in a universal and predictable way. It allows for addressing any subcomponent of a research object, including what Balaji calls a citation-less function calls. We can essentially use these pearls, these permanent URL, to import code and data components directly into Python or other programming languages. So we have that newfound ability to address with a single PID an arbitrary number of subcomponents of a research object. So yeah, happy to take questions and to talk about this.
I've of course always got questions, but for anyone who has a question, you are welcome to just unmute yourself. We'll be keeping an eye out for anyone that turns on their mic, and you can talk whenever you want. If you don't have a mic, there's a chat bubble you can click on next to the community voice channel. Just type it in there, and we'll bring it in as they come in. But just to get us kicked off, when people seem to be typing questions out, I'm curious about the sustainability or the long-term vision of having DCite foundations support the cost of publishing this stuff. Is there any idea on if that will ever sort of be forced to stop just because so many people are publishing and you just can't afford that, or what's the sustainability of that model?
Yeah, so our idea around that is to set up for example, a nonprofit around DCite or whatever domain we decide to go with, and essentially have a similar system as what the DOI Foundation is doing right now. So that's the idea around the sustainability. Now the thing that's powerful about that is that the only thing that matters is keeping DCite up and running, because all of the pearls, they're registered on a smart contract, so anyone can access them. We're not dependent on DCite.org. We can actually have a completely decentralized system that allows us to have secure, permanent identifiers without any intermediaries. And when you think about that, that's quite exciting because consider the current architecture of the scientific record. We have DOI.org at the top. We have laterally, we have partners like Crossref, like DataCite, like regional partners in different parts of the world. And they're essentially there to take input from publishers and other entities and to be minting a DOI, and quite often to also be recording metadata. So here we can now skip all of this complex structure and replace that with smart contracts that will produce these PIDs for us. And essentially, because we're using this technology, we can have a common namespace, right? We have a universal namespace that's built on the UID. And we then have the tamper-proof properties that are built using CID's content address. So the idea behind that is that we can remove a lot of the intermediary layers in the way that scientific work and scientific objects are indexed. And that's a much more effective solution, potentially.
That's very cool. So if I'm like undergrad or master's or PhD student at the moment, like how is this going to change how I might perform my research, or how the publishing, or how I might cite other people's resources? How does this affect me as I produce?
So you get the you get the most benefit from this system when you're using DCite nodes and you're creating research objects, because all of a sudden you have the ability to, with a fine grain, cite and for like a permalink to a specific piece of the research object, right? And so that is super powerful, and that's something that hasn't really been done before. And then what we're doing is we're making it so that's a bit more friendly for citations. So it's not like such a huge URL has like a friendly identifier, similar to DOI. And so what that enables you to do is also, you could also, similar to, other metrics, you could start gathering potentially metrics on these, individual citations. And then you can also, there could be a potential integration with like Google Scholar and these sorts of things to start seeing how the citation is performing, but it's all happening on a decentralized backend, which is really cool.
Right. So I'll be able to, instead of citing the entire paper, I'll cite the paper and then also just the one formula I use or the one paragraph that I'm using in my paper. So anyone who wants to verify any of this can go to that one section very quickly, run the code themselves, and then just move forward from there. So instead of having to go and read an entire paper trying to figure out why I cited it, it's just there.
Correct. We'll introduce varying levels of precision. Right now we're thinking about citing components, pages of a manuscript component, and then also files and methods within a code component, right? And so, but we'll introduce, varying level, increasing levels of precision into the way that you're, referring to components and referring to, parts of the research object. And then, it's certainly possible that you could get super precise, and that might be part of your workflow in the future. And creating a knowledge graph around that would be really interesting. That I don't think that would have been, kind of done to that level. But we're going to take it a step at a time and introduce kind of these certainly granular, but stuff like, hey, this is the page range I'm citing, right?
Yeah, and basically everywhere in the node product that you see a PID, persistent identifier, that's something we can easily essentially cite with that scheme. And another thing is that it's really convenient when you want to import a data set, for example, or you want to import a code container or a Jupyter notebook directly into your workflow. You can do that by using HTTP import in Python, for example, and there's other ways in different languages. So you can start to essentially pull these data, these article link data, in a way that is secure, that is version controlled, that allows you to simplify your workflow as a researcher and to aggregate all of those components that are essentially into a decentralized open state repository.
This is very cool. I can't wait for people to cite the word "the." That should be fun.
Yeah, and technically you could come up with your own resolution scheme on your own. We're going to provide a resolution scheme for nodes, but there could be different resolution schemes that can use this and benefit from it.
So one thing, sorry, so Sina and I were just talking about this earlier today, and one of the questions was do existing reference managing tools, would they support something like that? And I think the clear answer is yes, because they all basically have an option for you to cite a DOI or just a URL. And this is nothing else than a URL, and then you just describe it. I think it's super elegant.
So to start using it, really, it seems fairly seamless. The biggest lift would be to understand that what a node is and how those operate, and that they
exactly.
just have more components than a simple PDF. That sounds very streamlined. For anyone who's curious what a node is, we keep referring to it. There's a great demo out on YouTube. If you just search for DCite nodes, it goes through it all.
Yeah, and I mean, you can imagine, you can essentially send URLs around, and someone clicks it, and it runs a Jupyter notebook and replicates a result, right? So you can essentially start triggering compute behavior directly off a URL. And there's a lot of, I think, unforeseen types of things that people will be able to do with this powerful citation system, and I'm really curious to see how this evolves over time.
Very cool. And it's up and running right now. Like we can just go start playing around with it.
Yep, you can go register URLs on DCite.org. It's on testnet. It's our testing ground essentially right now.
Yeah, and basically in the coming few weeks, we're going to be rolling out the initial features for fine-grained citation. And so this will include the ability to reference code components as well as files and methods within the code component. And then the other part would be for manuscript components to reference a page within a manuscript component. And then we'll be adding more. We're going to be building out a specification for fine-grained citations. And we're going to be implementing that spec and basically coming to a point where we feel that the spec covers most cases, and then kind of like maturing that spec and then releasing the DCite.org system onto mainnet and then moving from there.
Very cool. Does anyone have any questions about the product here? I guess DCite, technical or otherwise. Otherwise, I have I guess a philosophical question. I'll give everyone a second here. Okay, yeah, I'm wondering then. So if we're going to be able to cite more than just PDFs, more than like get granular, what this does to sort of reputation scores, where in the current system a lot of it relies on number of citations and stuff like that. Has this been something you guys have been thinking about as you're building out new ways to cite scientific research and knowledge?
Yeah, absolutely. I mean, I think that's so there's a product out there called Fixture, and their value proposition is essentially, hey, you can put up your research artifact and get citations. You can have people start citing your figures, your data sets, other components. I think that's a strong element because to accelerate the pace of progress, we need to improve reusability in science, right? And it's been demonstrated already that making things easily citable increases citations and essentially allows authors to gather credit. That is a very interesting form of credit because it's related to open science. It's related to sharing your research artifacts. It's related to best practice in data management. And so if we can create a system that simplifies that even further without having to require a separate DOI for every subcomponent of your research by essentially having a Merkle DAG that contains all of it in a secure and tamper-proof way without relying on a centralized repository on AWS, but rather having all of those components on a fault-tolerant peer-to-peer network. Now, all of a sudden, we can increase the visibility of scholars that engage in positive open science types of work. And I think that's a general boon because it'll also reduce the barriers to reproducibility, reduce the barriers to achieving more replicable research. I mean, it's an incredible net positive that we could do with that.
Yeah, I mean, I don't know too much about citation or how the whole system works, so I can't really ask many questions on this. So I'm hoping there's some people here.
Citations are the currency of science, right? It's the currency of science. It's the single thing that counts. It is the the root of the KPI that governs all of science, which is the impact factor, and it is also very deficient as a single metric, and that's why we have to move towards improving citations of artifacts and improving reproducibility through verifiable attributes, and that's what we're going to do.
I guess the question I would have is if you can cite so much more easily in so many different aspects of different papers, should it be the currency of science? Is it going to continue being the currency of science at a level it is right now?
So the idea, I think, and this is for us very important, is that what we want to do is we want to recouple impact with reproducibility. We want to recouple impact with open science. Right now, we're relying on a monotonic metric, which is the impact factor and the number of citations gathered, and that's not. We need a more plural, holistic way of appraising these research objects. And essentially, that's what we're going to be doing with verifiable attributes. Because once we have that system in place, once we have a generalist repository where you can create, you can connect your reproducible container to your code, to your paper, to your PDF, to your manuscript, then all of a sudden we start being able to do things like verify proof of reproducibility. We can verify that the data has been shared. We can verify compliance with funder mandates. And that's a way to increase the visibility for these behaviors that are actually very, very good for science. And so we can better coordinate, create better incentives to essentially entice and incite authors and researchers around the world to engage in those behaviors and to be rewarded for it, all the while making the UX cost, so the user experience, a burden as low as possible with a good user interface, a good user experience, and a simplification of the entire publication workflow.
So maybe just to add to that, so from a perspective of a scientist who's like currently still influenced or like seeing the academic system as it is, so one game that academics often play is that they try to maximize the number of citations that they're getting for one particular paper, right? So it's typically better to have one paper with 1,000 citations than 10 papers with 100. And so one way that you try to do that is by making sure that people actually only cite one version of your paper, right? So this is one of the reasons why people are sometimes skeptical to put up a discussion paper in addition to the official published version, or to even have several versions of the discussion paper. And I'm just wondering, like, what will be the dynamics that academics will engage in once a fine-grained citation system like this becomes available, right? So I think they will definitely try to make sure that whenever they get cited for a particular research object, that all of these citations that they sort of aggregate at the top level, even though people can cite like at a granular level, they will want to make sure that they end up getting like full credit from all these micro citations to their overall research object that they've created. I'm not sure. This is like,
it's a very good point, and we can, with that system, we can accrue all the citations to every subcomponent to the top level object, to the research object, which is something which is much trickier to do, or actually not necessarily possible with other forms of generalist repositories and the DOI system.
It's going to be interesting to watch develop. I mean, it requires more people on nodes. When can nodes be open?
Exactly. I can't wait for this either.
Exactly. So we're planning to open it up in September. That's the plan.
Oh, that's so close. That's great. Go ahead, Blue Guy.
Yeah, that's so close. And we're also going to do the biology citation demo. So end to end, commit the object on chain, and get to the PID, so the secure UID/CID, which is registered on a contract. Then get that into the URL shortener to create a human readable and actually a digestible Perl permanent identifier that you can easily put on a website, and take that and import it. Use that
import it to Python.
and pour into Python, and then essentially execute or essentially pull the data, pull the code into Python, and then we've done the full end-to-end demonstration. So we'll have that by September.
This is Martin here from Fleming. This is great. So I've always wanted to be able to cite a specific paragraph or sentence within a paper. Now, my question now is that in terms of like reproducibility, right, or whether people agree with a sentence or a statement that you might have, how would you see that working here? So it's like thumbs up, or what percentage would somebody agree with a statement, or how reproducible people consider a statement to be? How would you see that factoring in here when you've got citations to a more granular level?
Yeah, so it's first of all, great to have you here, Martin. Thanks for coming. I appreciate that. For those that don't know, Martin works on Fleming protocol, which is a patient-centric protocol to help patient groups essentially fund or create or stimulate research for specific conditions that are not well addressed by the current scientific landscape. So how do we see this? So I think reproducibility is a very specific thing, right? It's the ability to reproduce, to recompose the results with the existing artifacts that the author has published and made available. All right. So replicability is different. Replicability is the ability to replicate the results given new data and in some cases new code. Right. So those two things are different. So reproducibility, the goal with nodes is to make it as simple as possible to verify reproducibility. That means an author can come and connect his Jupyter notebook, which essentially allows him to reproduce the main results and regenerate the figures in his papers, which generally contain the main results, and essentially link this Jupyter notebook or executable container on CodeOcean or something like that to essentially link that directly to his manuscript in a way that is secure and tamper-proof, so that a third party or an observer can come in and essentially rerun that code to reproduce those figures and to see how the author got to the process data and the final results, right? So that is verifying reproducibility. It means that we can now create an attribute system where you have badges, and you have badges like the badges of the ACM, which say, hey, your results can be reproduced given the artifacts that you have made available. And we can now have that system of open verifiability, which we've been talking about a lot, which essentially says, hey, let's allow learned societies and decentralized groups of scientists to essentially verify the attributes of these research objects and to reclaim the value of curation by doing that. And the whole user experience of this is simplified because everything is there in a single browser-based experience that's served from a gateway. So that's the idea about how we plan to essentially verify reproducibility in a way that returns value to scientists, but is also trustworthy and simple to do.
Okay, yeah, very cool. So you probably heard the DCite podcast with the Molecule guys and Balaji on that. Is that where you were referencing when he had the kind of computable papers?
Yeah. So Balaji has this idea of citation as function calls. And by the way, we have someone in our community who has been working on this too, and who has made a cool graphic. And he's here. Actually, his name is Manveer. Hey, Manveer. Great to have you here. Maybe you wanna say a few things about the chart you published and your ideas around it.
Hey, yeah, no, thanks for having me. Honestly, I just kind of saw Balaji put that up at the end of his podcast, like a proposal essentially to build a demo for that. So I just kind of like spent a little while putting that together. Just thought I'd like share it around and like kind of like show the broader community what's really possible with DeSci, because I feel like there's a lot of people, especially even within like open access science as well, who are like kind of interested in knowing how decent help propel the movement forward, but might not necessarily know how it like works. And so like the whole purpose of that demo was just to kind of show, and hopefully like the easiest way possible, like what's theoretically possible, if we can put papers on chain or like just like on decentralized systems.
Yeah, I think that's insanely valuable. Go ahead, Martin.
Yeah. So yeah, in that podcast, Balaji said that as soon as someone's done, he basically said, "Look, get in contact with me. I want to see this happening," and almost saying like, "I'll give rewards to whoever can show me this working." So you should try and get in contact with him about that.
Yeah, he retweeted what I put up, and I think we're like having a DM convo as well on where this could potentially go.
Oh, cool.
That's very cool.
So I mean, that's great. Great to have you in our community. Thanks for having, sharing these interests, and I look forward to brainstorming with you and chatting about these different modes of implementing these citations as function calls and all of that. And I think that's a really valuable thing if we can have community contribution and just putting our minds together to see how we can do this in a way that's viable for scientists, that gives a good user experience, that's secured. Looking forward to see what comes out of these discussions.
Yeah, definitely. I think there's a lot that we can do. We can definitely have a huge impact if we put our minds together and like really execute. So yeah, excited to work with you guys.
Yep. Next step for us
Awesome.
we have a full plate right here. And by the way, if anyone's interested in helping, we have some open positions, and we're actually happy to entertain collaborations on building some of the components for that. And I think really, in general, it's a huge interesting challenge, because we're at the frontier of engineering as well with decentralized technologies. There's a lot of very interesting technological choices that need to be made about, for example, anchoring papers on chain, about running reproducible containers in a way that simplifies the experience, about creating secure pearls that are friendly to academic while maintaining their cryptographic security. And this has been, for us, I think now, this is probably the most interesting and intellectually stimulating phase that DeSci Lab is experiencing. So, we're stoked about that, and we're definitely looking for to share our progress and to bring on some good people.
Yeah, it's fun to watch, and I think it's insanely important what you guys have been talking about, the just making it usable and approachable by people who are already in the system, where they're to the point where they're like using this technology without fully appreciating the technology, like the infrastructure behind it and how it's working. And to that extent, it seems like, I've been playing around with DCite nodes a little bit, and now with this DCite thing, it's to the level that even the general public can sort of dive into it and teach themselves how to, for lack of a better term, do science, similar to how open source made it so the general public can jump into software and learn how to do software without formal training. It's very exciting to watch.
Yeah, that's really our goal. So we're very much user centric and attuned to the workflows of scientists, the scientists ourselves. And we know we have to make the experience as simple as possible for people to adopt it, and we also cannot shock them out of their existing habits, right? So we need to have a form of cultural interoperability, and the simplest way to do that is to have essentially a browser-based experience where people can aggregate their research outputs very simply by copy pasting and drag and dropping and things like that, and then allowing that to show them cool results in a very limited time without having to go through complex CLIs and other types of methods. And by the way, I want to thanks again all our beta testers, some of which are here today, alpha testers actually. We're really excited for all the reports you've posted. We're going to be pushing out some improvements as well. And keep going at it. It's great to have you. And we're really looking forward to improving the experience and to improving the range of capabilities of this generalist repository.
One quick question with the tech and the relation of DCite to DeSci nodes. Now, as a note, I was not here for the first couple minutes, so you may have gone over this. But in DeSci nodes, it's all in a PDF viewer. So when you're citing that paragraph as integrated with DeSci nodes, would you ever be able to, for example, like click on the citation and have a pop-up of the text? Or will you not be able to do that because PDFs essentially are a picture of text?
Oh yeah, you can do that. You can do that. You can actually put tattoos into a PDF, and you can essentially now take your PDF and share it with your friend. And essentially, when that person opens it up on his desktop, he can essentially click on those links, and they will resolve on DeSci nodes. Right? They will go through DCite, and they will be resolved on the gateway that has created this research object. And so that is interoperability at the social level, right? Because you're not breaking the habits of scientists, and you're allowing them to move from a very familiar environment, which is a PDF viewer, to a environment which is an enhanced viewer, which allows them to interact with code, which allows them to run a Jupyter notebook, which allows them to watch a video presentation or a talk without shocking them out of their existing workflows. And so we can definitely do that, and that is the power of these permanent URLs, pearls.
So then, also in terms of citing specific text, we can. So we're building that out as well. Kind of the ability to have really fine-grained citations beyond just pages, but we also are going to have pages. But then also selecting specific text. We can actually read the PDF. So the PDF actually has a text layer. And so we can actually read the full structure of the PDF and understand actually between two PDFs what's changed. So we can do this sort of thing. And we can also use this capability to implement fine-grained citations like what you've described, Ellie. And the challenge for us is just implementing these features. They're kind of like, there's a lot of features to implement, and it's still kind of like we're working through building all this out. But it certainly is possible, and we'll be using the ability to read the structure of a PDF in various different parts of our platform of the DCite nodes experience.
Okay, sweet.
I'm curious from a distributed computing perspective, which is some of the projects I work on come from distributed computing. Let's say I have a data set and I have a application that crunches that data set for a specific outcome, and let's say it's math, it's like prime numbers. Let's say I publish a paper on how that data set or how that application works and some of the results I've gotten from it. Will someone then be able to just access that publication, take the data set, and build a different application? And is that going to be a very streamlined process? Am I making sense? I'm not sure if I'm communicating this very well.
The one thing I'm confused on here is what is application?
The way the data set is analyzed in the software.
Mm-hmm. I see. So would this be like a Python notebook or something else?
I imagine. I don't know the technical language to use, but I know that people will post a data set and then run it in different ways using different software.
So you could have different software to process a data set, right? And so the way I'm looking at this is that we have an ability to have every single node, DCite node, like a research object that refers to code, be referring to a like an IPFS CID of the root directory of the code, or otherwise, it could be a zip file, could be a lot of different things. But we think that root of a CID directory, and so then you could then load that up into something. Well, actually, let me share my screen. See, the thing is, actually, I wanted to share this once we had it integrated here, but so let me see. So if you go on GitHub, and you press dot, this VS Code pops up, and you can actually. So I've gotten this running with an iPod, like a Python notebook, locally on this experience, and I got it running locally as well. And so what we can do with this is actually, we can in the browser make use of the VS Code open source web extensions and run various different types of code, and then that's going to be a seamless experience. And then I'm sorry if I missed the last part of your question here.
No, I think that's it. So the code will be posted in a node, and then I could cite that code in my separate
Correct.
node and just sort of build on it, tweak it, or complete it. Write a
Yep.
completely
Yep.
new
That's the full circle, right? That's the full circle. So there's different ways to do that, right? One is in your local environment. So you just have your local Python set up, and you essentially use HTTP import from the Perl, the permanent URL, and there you can HTTP import, the PID of the node / the data, get the data. Maybe it's a CSV file, and now it's now you have CSV file.
I think. Sorry, I think I remember the part that I was missing. So the part that I'm missing here is that so you could have one data set stored in an IPFS, right? That has one CID, right? And then actually any other research object can refer to that. So let's say it's the CC0 or otherwise openly accessible data file, right? You could do that and load it up into your code and maybe perhaps pass in a CID, right, for that data set. And then you could have multiple research objects pointing to the same data set, processing in different ways. And that's one of the workflows we want to support, right? And then we can also, there's a lot of cool stuff that you can do with that model. Like, you could encrypt the data if you wanted. You could also, so there's a couple of different things, like in terms of like having research teams, kind of like have data amongst themselves, right? Perhaps, and so we want to work out a permissioning scheme, but initially it's going to be for open access data. We'll be able to refer to it from within these code containers.
That's really cool. So it sounds like this, like on a larger scale, might actually help push open data more to the forefront, where instead of people hoarding the data they work so hard to get, they're sort of incentivized to publish it, because first they're going to get credit because it's an immutable ledger that shows that they published it first. And then once they publish it, lots of other people can do cool stuff with it. So it'll help their impact score, the reputation, to see it cited by all these different nodes so many times.
Yeah, it's going to be really interesting to see, with these tools, what people end up doing. But I think that, like, personally, I think we're going to make it really easy to do the work with shared data sets that are open. We're going to make it super, super easy, and it's going to be really cool to see, like, when we traverse through all the different, research objects that have been referring to the same data set. You could get some really interesting kind of like progressions of different research. You can see it over time. It could be really cool.
September.
Well, I mean, okay, so what we're launching with, for the beta is going to be the ability to do fine-grained citations, and then what we want to support also is general compute, right, on the code. However, with the general compute stuff, we do have a bit of work to productionize this to make it scalable, and we have a plan to do that. I think that's going to be a stretch goal for us, but I think that this is definitely something that we think makes the system complete.
It sounds like a lot of fun. Are there any other questions that people have about DCite? Or, I mean, DCite, we can open it up to anything at this point, DeSci Labs related.
Yeah, absolutely. I mean, just go out there, throw any questions. Feel free to speak up.
I'm fresh out. I'm blaming Monday because why not?
Yeah, I mean, to go back to your question, I guess the ultimate end-to-end loop is you create a second DeSci node and you essentially import you essentially have in your reproducible container the importation of the code of another DeSci node or code or the data or a function or whatever that's into that DeSci node, and you have that happen in an executable notebook, right, or into a container. And so now you've fully closed the loop. And I'm really curious. I think this opens up a range of perspective and possibilities that for us, I think at this stage is hard to imagine. It's hard to imagine to just think how people are going to use that. The only thing we know for sure is that if you give people affordances, you make it easy to use, and you create you create incentives around it, then people are going to start using it, and it's going to be interesting to see what comes out.
Yeah, I'm personally interested in how this is going to integrate with the badge system and the whole reputation and impact factor, like the restructuring of impact factor through the node system as it all develops. It's starting like a complete picture of what's being developed here is starting to take hold, and you can see how each part is going to play with one another. So it's just fun to watch get pushed out there.
Yeah. The attribute system is something we're really excited about, and I think that the attribute system. So this is like you say. So the different components, they play off the strengths of each other, and they're more than the sum of their part. So essentially, if we create a good tool, good user experience on the citations as function calls, permanent identifiers, and composability of knowledge, if we create a good experience there, then the question is like, okay, so we can now allow researchers that go beyond the call of duty and actually do things according to the best practices in open science to have recognition for that. And that recognition will have eyes. That means, funders will pay attention, philanthropists, people that are interested in open science. They'll be able to see those types of practices by individual researchers, and that's going to contribute to their reputation. So now people are going to start having an incentive to share their research, to create more reproducible objects, to essentially engage in those types of behaviors that make for a more replicable and robust scientific record.
Yep. Can't wait. Wish it was done. The entire thing, not just DeSci Labs, but all of DeSci. It's just working on so many different projects. And it's weird. I went into just a non-DeSci related science community recently. I just mentioned, hey, I'm interested in meta science and open science. And more than one person was like, what's that? So it's going to be interesting to see what happens if people start using this technology that they don't they don't know is built on open science and sort of the principles that come with it, but they're using it anyway. So they're all of a sudden performing open science because they're incentivized to do it, but they're just like, I didn't know it was a movement that's been around for decades.
Oh yeah, no. I think in general, like scientific communities are so huge, varied, and scattered. I mean, I'd be surprised that essentially people now are very familiar with open access, but there's, at least in the general public, there's that lack of understanding of the brittleness of scientific results, of the replication crisis, of the essentially what sets apart this new study that came out in Nutrition Science that found some correlation that then a journalist takes on and frames it as a causality to get clicks, and people don't essentially. I think that there's not yet a good awareness in the general public, and perhaps that's by design about some of the grave problems that science is facing right now when it comes to the replication crisis and the problems surrounding the incentives for reproducibility. But at the other end of the spectrum, funders are keenly aware of that. And you have now, for example, at the NIH, they mandate a data management plan. The European Union has invested hundreds of millions of euros into the Open Science European Cloud solution. There's been all of that top-down effort and these major tenders that have gone to software contractors over the last years to essentially try and build infrastructure to promote reusability of scientific artifacts, to promote the FAIR principles, to improve reproducibility and replicability. So there's that awareness at the level of the funders at the highest level. So that's perhaps a gap in education in general, and I think DCite can really help increasing the awareness for these problems, and also help improving or essentially amplifying the voices of researchers that engage in the best open science practices possible in a way that is recognizable and verifiable, and that will allow them to gather honors.
Chris, Martin here again. A thought that I had during the week was around reference managers, and it was in the context of the whole Mendeley and then Zotero. So I use Zotero now. How would you see kind of integration with reference managers working in this situation?
That's a good question. So we will make it, we'll have a simple button to import in reference manager. That's not an issue. I guess the broader philosophical question is, why do you need, let's say, the boilerplate around the reference anymore if you have a permanent identifier that doesn't break, that guarantees that the underlying content is tamper-proof? Does it still make sense to say volume 16, page 293 to 300?
Yeah.
It doesn't really make sense anymore, right? Because now you have a cryptographically secured, tamper-proof, decentrally stored permanent record of the underlying object. And so while we will do integration to essentially import those in your reference managers, because we think that there's still, ceremonial value and cultural, that's not the type of habit that we have the ambition to change. But when you look at it on a longer time scale, it's possible that these types of permanent links that are indexed on a contract will essentially come to change the way references are made, right? And they will be done using hyperlinks, so they'll be done using a different method without all the boilerplate around them, while still allowing scientists to track their impact and the number of citations that they've gathered.
Yeah, fair enough. I suppose it goes to the question that how are we going to manage all of our gathered, I suppose, citations or gathered nodes that we, when you're going through your scientific literature and you find things you like, and now you put them into Zotero or whatever your reference manager is. The question goes to, what's that going to look like when everything is on chain and distinctly citable?
So it's probably going to look like the only thing that'll change is the DOI. It'll become a decentralized PID. So that's the DOI link when you insert citations at the bottom of your text with Zotero or Mendeley. So that'll change. The question then, I guess, is what's the subtext within that metadata of the reference, right? Do we essentially say, hey, you're actually citing here data set. Hey, we could actually take the type from the metadata from the self-describing JSON LD metadata we have, and we could actually take the type and essentially use the type as and put that in the boilerplate of the specific citation. So perhaps you'd have the name of the authors, then you'd have comma, data set slash the permanent URL. So something like that could work. And we don't want to shock scientists and scholars, out of their habits. I think it's very important that we're mindful of all the cultures and the ceremony around that. And so we want to make it as interoperable with current culture.
And basically also in terms of like fitting in with Zotero, my understanding, and correct me if I'm wrong, is that you have the ability to enter a link, and then I wonder, is there anything else that it does that you're concerned about?
Well, I suppose if I'm looking at Zotero and I have a list of all a load of DCites in there, right? So like a paragraph, you almost want to see in that the kind of cryptographic assurances it's almost like Zotero
I see.
would become a wallet.
I see what you're saying. You want it to signal that this thing is valid and that sort of thing, that the link is
Yeah,
valid and that the citation is valid.
yeah. I'm just thinking out loud, really, but it's
Mhm.
within when I'm using Zotero, because Zotero is open, right? We can make changes to Zotero and add them in relatively easily, like rather than recreating a whole new reference manager system.
Oh
I
yeah, I
see.
think we definitely want to allow easy importation.
Yep.
The question of whether the link is secure, I mean, the beauty of it is that anyone can verify it, right? So it does, because of its unique structure with a CID, content identifier, you have the guarantee that the underlying research object has not been tampered with, hasn't been changed, hasn't been stealth edited, hasn't suffered from content drift. And as long as the gateways on the IPFS network, they pin content, then you have you have like the assurance that the content is available. And even if the content's not available for whatever reason, perhaps because it goes against some terms of services and is infringing copyright, well, you can still have the metadata. So we have that ability to essentially protect the content of these links and prove that the underlying objects haven't been tampered with. And because the repository is open state and relies on the IPFS network, you'll be able to see things like the number of copies that are pinned on the network, and so that will give people transparency around what's the status of the stored research objects. And then, of course, there's the possibility of doing things like backing up everything automatically on Filecoin for long-term storage, and then having the ability to restore content and things like that. And the also another important part is that we want to make this graph as robust and portable as possible. So these are some ways to think about that.
Very good.
Awesome. We have time for one last question in the chat. Here is coming from Manveer. He's asking the approximate idea for when developers will be able to start building on the infrastructure getting built out here.
So yeah, I think that we're going to be releasing specifications for all the different schemas that we've discussed, around September. So when we along with the beta launch of this, so that folks can review it, we think that's important. And then there's going to be components, that implement these specs that will be also made open source. And that I think is important because we want to be able to integrate with various other tools and approaches, and so we'll to the point that we can enable that. That's a good thing. And so that's our general plan, and I think that we'll have a release schedule that we publish, along with like every component and its open source release as well.
Very cool. It's nice to see that people are already excited to start tinkering with this stuff once it comes out. Yeah, on that then I guess we'll wrap up, and I'll leave it with this one quick thought in response to what Chris was saying earlier about open source open science starting to get a lot of funding and more attention from the top-down approach. I'm wondering if that's because the people currently in the positions to actually implement that stuff from the top grew up with the open science movement sort of in the 90s and early 2000s, pushing it, and so they just think it's the way things should operate. They have nothing else to go against it. So it makes me wonder what, in 20 or 30 years, people who are growing up with the DCI movement are going to just implement from any top-down mechanism they might be in charge of to push science into a more open direction. I think there's a lot of optimism in the idea. So that said, we'll be back. Well, we're sticking around for an hour. Anyone's welcome to just join us and chat about anything that's been said here, anything else you want to talk about DCI or DeSci Labs related. Otherwise, we've got our community call next week, noon Eastern here, and there's a bunch of calls throughout the week. Stick around in Discord if you want to get more information about when you can join us for those. Otherwise, thoughts, Sina, Chris, Philip?
Great community call. Thanks everyone for joining. I really enjoyed that. I'll be chilling in the cafe for a while, so we can have some open conversations, and then back to building. So see you all.
Yeah, and anybody, if you have any questions for me or any questions on the specs and the ideas that we discussed today, feel free to reach out, send me a PM, and I'll stick around here for a bit.
Yeah, and if you have great ideas, I mean, I think there's a lot of brain power in that community, and we're really happy, to exchange at a high level and essentially make things better together.